While it makes sense to represent characters with numbers, how could we possibly represent something like a color as a number? One system that is used in the real world is to create a catalog of numbered colors. This is used in graphic design, artist supplies, and paint stores. In the early days of computing, they used a similar system of assigning numbers to colors, and it is still used in a few applications. The problem with this approach is you end up with a very limited number of colors, or to borrow a term from color theory, a very limited palette. The easiest case to consider is how to represent different shades of gray. Despite what you may have heard, there are more than 50 shades of gray. In reality, colors and light intensities are continuous, so there are an infinite number of shades of gray between black and white. Of course, we need to discretize them. In practice, using 1 byte to represent a shade of gray is quite common. We can represent the numbers 0 through 255 in a single byte. We will assign 0 to black and 255 to white, and then every number in between will be a shade of gray, slowly progressing from black to white. For example, 200 would be a light shade of gray, while 50 would be a dark shade of gray. A very small number like 3 would almost be indistinguishable from black. To represent the full spectrum of color, we need to understand some color theory and how colors combine to make other colors. There are 2 core ways of thinking about combining colors: subtractive and additive color theory. When you were a kid, you were probably more familiar with subtractive color theory, because when you mix paints or crayons together, they become darker. If you mix green paint and red paint, you'll get a yucky brownish paint. It's called subtractive color because combined paints will absorb more light or take away light. The color theory that is used by most computer displays is additive color theory. Additive color is what happens when you combine colored lights together. Instead of becoming darker, they become lighter. Imagine that you have a green flashlight and a red flashlight. If you combine them, you will get a yellow light. For additive color theory, the 3 primary colors are red, green, and blue. By combining different intensities of those 3 colors, you can get pretty much any color that you could imagine. They are almost always in that order: red, green, blue, or RGB. To help remember that, if you know your rainbow colors, that's the order they are in the rainbow, Roy G. Biv. Or if you prefer, they are in reverse alphabetical order. Similar to what we did with grayscale, we will use 1 byte for each color. 1 byte for red, 1 byte for green, and 1 for blue. This is 3 times 8 bits per byte, which equals 24 bits. 24-bit color is the most popular method of representing color in televisions, phones, and computer displays. Unless your display is ancient or very expensive, you are viewing this in 24-bit color. Just like with grayscale, the intensity of each color will be in the range of 0 through 255. So for red, 0 would represent black, and 255 would be bright red. A low number like 50 would be dark red, and a high number like 200 would be light red. One convention for specifying 3 intensities of red, green, and blue is to write it as an RGB bracket number, comma, number, comma, number, close bracket. The easiest way to see how this works is with a few examples. RGB 100, 50, 200 is medium red, very little green, and a lot of blue. When you put that together, it creates a nice purple. If you increase the red to 200, then it becomes a nice pink. If you then increase the green to 200, it becomes gray. If all 3 colors are the same intensity, then it becomes equivalent to a shade of gray, as we discussed earlier. RGB 000 is solid black, and RGB 255, 255, 255 is solid white. In practice, representing 24-bit color as a 6-digit hex code is very popular because it is very compact and easy to use once you get used to it. To show a hex color, it starts with a hashtag, and then each color in the order RGB is 2 hex digits. Following this convention, FF0000 is pure red, 00FF00 is pure green, and 0000FF is pure blue. All zeros is black, and all Fs is white. If you Google hex color, you can find a wide variety of tools that will allow you to experiment with different colors and see what their corresponding hex code is. As a tip, remember that the most significant digit in a 2-digit code is the first number. So if you see a code like F37E0B and you just want to get a sense of what the color is, look at the most significant digits, F70. That will be a lot of red, F, medium green, 7, and almost no blue, 0. We know that red and green make yellow, but this has more red than green, so it will appear orange.